Hello, let's continue our Sudoku adventure with Building 34 by Sanabas. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these clues outside the grid. These are skyscraper clues. So the way these work, let me just fill something out here like 2, 4, 3, 1, 5, 6. So starting from where the clue is, I'm going to mark in green any digit that is bigger than all the previous ones. So 2 is bigger than nothing, so 2. And then 4 is bigger than all the previous ones. 3 is not bigger than all the previous ones. I'll make that red because it's smaller than the 4. 1 is definitely not bigger. And then 5 is bigger than all the previous, and 6 is bigger than all the previous. So you can see that the green digits strictly increase as we move right to left. And so the count of how many green cells, how many match that criteria, is this 3. So this is 4, that's 3. This doesn't actually match the clue. If we swap the 5 and the 6, though, then now the 6 is seen, but the 5 is not, and that would match the clue. So this would be one way to do that row. We also have counting circles. A digit in a circle indicates exactly how many circles contain that digit. So basically, if a digit is in a circle, it's in the circles that many times exactly. So if a 2 is in the circle, it's in there twice. If 2 is not in the circle, it's not in the circles, right? But so like a 5 would be 5 in 5 of the circles. And in addition to that, if a counting circle is in the same row or column as a skyscraper clue, then the cell is seen by the skyscraper clue. So it would be green in that example. So the example is given as row 5, column 4. If that is seen by both the 3 skyscraper here and by the 4 skyscraper here. It has to be bigger than all the previous ones. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I'm going to actually use coloring for this, but it might be hard with the columns and the rows intersecting. So maybe we'll just do without the colors for now, and then we'll color if we need to. These two are both seen. So that means we only see the 6 afterwards, but there's not much to say about that. I'm going to actually, okay, so the first thing we want to do with counting circles always is count them, which is, I don't know, that's kind of apt, isn't it? So we have 2, 3, 4, 5, 7, 10, 11. So there's 11 counting circles. Why did we count them? Well, the sum of the unique digits on the circle will equal the count, which is 11. Because if we put a 2 in there, there's 2 2s. If we put a 3 in there, there's 3 3s. And so each digit uses up as many circles as itself. And so we can just add up the unique digits, the 2 and the 3, and you can see that we've used up 5 cells. And so now the next thing we want to think about is how many unique digits must we have? I'm seeing, in this row, in this box, we have at least 3 unique digits. I think 3 is that we could have 4 unique digits because we could do 1, 2, 3, 5. But with 3 adding to 11, it's a bit more open. So it's either 3 or 4 unique digits. Okay. Let's see, what else can we do? Is there anything skyscraper-y we can do? So penciling large skyscrapers can be helpful. Because if, like, let's say I put a 6 here, this is the extreme, but if I put a 6 here, that should be a 1, right? So big digits next to a clue restrict how big that clue can be. So 5, we would see the 5, we'd see the 6 wherever it is, but that would only be 2. A 4, we'd only see 3, right? So this is from 1, 2, or 3. 3, we could see 4. We could see 3, 4, 5, 6 in order. And so this next digit, though, how big can it be? And the biggest it could be is a 4. If this was a 5, we'd still just see this one, the 5, and then the 6. That's only 3. 4 does work because the 4 doesn't hide this 1, 2, 3. So we see this one, we see the 4, and then we could see the 5 and 6. So it just increases by 1. So you can kind of pencil this way, and now we know the 6 is over here somewhere. Okay, the other thing we should have looked at with counting circles is it possible to put a 6 in them? Because it requires having a circle in every row, every column, and every box. And that actually is true. Every single row has at least 1 circle. Every column has at least 1 circle. And every box has at least 1 circle. So we can't put a 6 in a circle. We're limited in where the 6 could go. But anyway, so the 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. But we know that these are seen. So this is actually a thermo in addition to being 1, 2, 3. So this can't be 1, this can't be 1 or 2. All right. Now the threes start 1, 2, 3, 4. And then they go up to 1, 2, 3, 4, 5. But this one, because this one's bigger than the previous, it is seen by the skyscraper. That can't be a 1. Okay. These kind of interact, don't they? I mean, the 6 is one of these two. 6 is up here. 6 is down here, for what it's worth. Oh, okay. So we've just proven that this box does not have a 6 in a circle. So we can't actually put 6s in circles, and that's huge. That means this is a 6. Well, I don't know how huge that was, but it placed a 6. So we can't use 6. So the thing is 3, 4, 5 adds to 12. So we could do 2, 4, 5 if we wanted. So we could still do it in 3. And this lets us do 2, 4, 5. Let's see. I wonder if these do sum to 11. They either sum to 11 or less than 11. Something to think about. What else do we have going on here? So no 6s in circles at all. I don't know if, I mean, I have some things already marked as 1 through 5, but I don't know how many I want to do that way. All right. What next? This circle is seen. Does that make a difference? Yeah, okay. If this circle is seen, you also can't put 6s before a circle that has to be seen, because the 6 is going to block it. So this is a 6 and this is a 6. And then 6 is one of these two. But this circle is seen by the 3. So this 6 better not be there or it would block it. So that's a 6. This 6 would still block it from the 3. So that's a 6. That's a 6. This has to be actually pretty large because it needs to be seen this far away. I'm pretty sure it has to be the 5 then, because the 6 is behind it. And so wherever we would put the 5, it would block this digit. So it better just be the 5. So now we know that we need 5 5s. So all but one row, all but one column, all but one box. What do you do with that? This column only has one in this one. Okay, this circle, okay. This column doesn't have a 5 in it. So all the other columns do need a 5. So this needs to be a 5. This column needs a 5. It can only go here. This column needs a 5. It can only go there. And then where's our 5? So row wise, we could have, okay, so there's a 5 in one of these two, but I don't know which. I don't know how to mark that. I don't really want to corner mark it, so we just won't try to remember. Oh, actually, we can just do Sudoku. That's even better. By Sudoku, 5 is here, and that places the 5 here in this box. 5s are done. 5s and 6s are done. Very nice. So we have to see these two, so that just follows the Thermo rule. We're seeing the 5, we're seeing the 6. Whatever this is, that works. Yeah, I think that by the same logic we had over here, this needed to be 5 also. I just didn't have to use that logic this time. So we only have 1, 2, 3, 4s left. So with a 5 in the circles, the rest of the unique digits add to 6. So they could be 1, 2, 3, or they could be 2, 4. So there is going to be a 2 in the circles. It can't be 1, 5 because we already have the 5. We can't do 1, 5, 5. That's not unique digits. So there are 2 2s in the circles, but I don't know what to do with that info. Okay, I don't think there's more Sudoku, but I'm wondering if there's more skyscraper stuff to do. We need to see 3. Okay, we see this one, the 5 and the 6. Here we need to see 3. I think this is key. This can't be, okay, well, this must be a 4 because it has to block these 3. And then we see the 5 and the 6. So it has to be the 4. So these are from 1, 2, 3 now. How about this 4 then? We see these 2. I mean, yeah, this could be 3, 4 for all we know. As soon as we put a 3 in a circle, we're going to be doing 1, 2, 3 as unique digits. Just to kind of point out. Because we can't do 2, 4 if we have a 3. What skyscraper am I missing? This 3's done, this 3's done, this 4 just needs these in order. This 4 I haven't thought about at all. Right, we have to see all 4 of these, so they'd better be 1, 2, 3. Okay, so that's one of our 2s. This is now a 1, 2, 4. This is 1, 2, 4. What am I doing with that? So, yeah, this can be anything, and it fulfills our 4 here. I just was ignoring this 4. I wasn't looking at it, so that's why I'm going through them all. That 3, this 4. So this 4, we need to see this one, which we do, and then we need to see one more over here. So we're going to see the 4, because this doesn't block it. And that 4 is the 4th one, so it better be... I don't know what to do with that. Because it could be over here. We'd just do 3 here and a 4 there, and that would be fine. If this wasn't 3, then we'd have a problem. We'd have to put the 4 here or here. We'd have a problem with the 4 here is what I mean. Is there a counting circle thing I can do? We need another 2. And then it's either with a 1 and a 3 or with a 4. So the other 4 are either going to be 1, 3 or a 4, but I don't know. Okay, the question is, can we put 4 4s? No, we have 1, 2, 3 columns left. So we're not going to be able to put a 4 into the circles. So no 4s in circles. That's a 3. That's a 4. These aren't 4s. These aren't 3s. That's a 1, 2 pair. That's a 3. That's not a 4. That's not a 4. 1, 2 pair puts a 4 there. So we need a single 1. We need one more 2, and we need 2 more 3s. Well, the 2 more 3s have to be in these 2 columns, because this column can't have a 3. So that's a 3 and that's a 3. All right. Unfortunately, that doesn't restrict the skyscraper at all. Here we need 1, 2, 4. That's not a 2. In fact, this is a 1, 4 pair here. This is a 2, 3 pair. That's 2, that's 3. Maybe it's just Sudoku now. Plus... one, yeah, this is a 1, 2 pair. I wonder if that's interesting. It is interesting. One of these is 1, one of these is 2. I guess I could make that purple then, right? Because we need 1 more 2, 1 more 1 in the counting circles. And so this sees them both. This will see the 1 and the 2, wherever they go, because it's 1 of each. So that has to be a 4. That's 1, that's 4, that's 2, that's 1. All right. And now we can just Sudoku it up. That's 1, that's 4, that's 2, that's 1, that's 2. Here we need a 1, here we need a 2, and we're done. That was a cool puzzle, Sanabas. I enjoyed that. I was fully expecting it to be 3, 4, 5. Or what? No, 2, 3, what? Yeah, 3, 4, no. 2, 4, 5. But yeah, interesting that it ended up being 1, 2, 3, 5. All right, cool. Well, how'd you do?